Hi everyone, my name is Gigi Goochey and I'm here in Hawaii, and today we are going to talk about the sarcomere. The sarcomere is actually the functional unit of a muscle. It's down inside the cell of the muscle, and there are several of them, many of them, and they are so tiny that we can have long strands of them inside the muscle also. If we took one of these pens, I'm going to say that this is the sarcomere, and then we're going to attach another one to it, and then we're going to attach another one, and essentially we make these long lines of sarcomeres and we call them filaments. These long lines of sarcomeres that become filaments, we add them together. We're going to add another line of filaments or sarcomere chain, and we're going to add that together and then put one on this side. And as we do that, then we're going to wrap it. And we're going to wrap it in what's called fascia of the body, or kind of saran wrap, something like saran wrap. We're going to add another layer of these bundles of filaments and wrap that in fascia, and add another layer and wrap that, and we're going to continue to bundle these, and as we bundle them they become the big muscle, and that outermost layer of that fascia is called the epimysium, and now we have that big muscle that we tend to see on our arm. And that big muscle that we tend to see, if we want to actually break it down and look into that smaller part, then we got to take the epimysium off, we got to take that bundle off, take the next bundle off, take the next bundle off, and go all the way down into and become a muscle cell. Inside the muscle cell, we have this long chain of sarcomeres. And this chain of sarcomeres is called a filament, like we said. And if we break it up, take one off, take another one off, I just want to talk about one sarcomere. And using your hands is actually a really great tool to illustrate the sarcomeres. So if you take your hands and put them like this, get your thumbs kind of out of your sight line, then when you're looking here, you look at your knuckles, and that would be one end of a sarcomere, and the other hand with the other knuckles is the other end of the sarcomere. We're going to call those ends the Z-line and the other Z-line. And as we do that, we notice that attached to the Z-line is something called the actin filaments. In the middle, if we add to our picture here, we're going to add some pencils, and we'll sight them in, put them in between here, and then see if you can get them on the other side properly. The pencils are known as myosin filaments. So the fingers are the actin filaments and the pencils are the myosin filaments. And as the muscle contracts, it's going to slide across each other and then slide apart. And when you are looking at this, what you're going to notice is that there's an area in the middle where it's only myosin filaments. Those myosin filaments that are just in this area, we call that the H zone. If you actually put a dot right down the middle, we call that the M line, or the middle. Where the area where we're going to have the actin myosin overlap, that's called the A band. Where you only see actin, see how from the Z line to where the pencils start, that's only the actin there, that's called the I band. Now when the muscle actually contracts, we're going to change some of those names, because when the muscle contracts and fully contracts, I lost one of my pencils, we lose the H zone. H zone is gone, right? The area where there's only myosin, that's gone. We also lost the I band where there's only actin. As we come back into a full relaxation, we're going to find that we get that H zone again and we get that I band again. And that's how, if we did an electron microscope of a muscle cell, we could see whether it was in contraction or relaxation. Contract and relax. If we want to take this just a tad bit further, and we're going to look at the myosin filament more specifically, it's kind of a thicker protein that has these things that stick up all along it, and in Hawaii we make these tea leaf leis, and these things stick out. And these things that are sticking out would actually be the cross bridges. Some people liken them to golf clubs, and these stick out all along the myosin filament. And if they were here, these little things sticking out are looking to contract to or attach to the actin filament. The actin filament is like a strand of beads, and two strands, double strand of protein. What we want to do is we want to take another strand and cover up parts of this actin filament. And as we do that, as we take this other strand and cover up the actin filament, we're covering up the spots on this actin filament that the myosin would attach to. The myosin is here, and it would attach to the cross bridges. The cross bridges would attach to the binding sites on the actin filaments. If we want the muscle to contract, we're going to just simply move the tropomyosin out of the way and allow the cross bridges to attach to these binding sites, because now they're open. The muscle will go into relaxation, and the tropomyosin will cover up those binding sites. In contraction, the tropomyosin will open up the binding sites. And that is the anatomy of a sarcomere. Thank you.